to permutations with repetition. So now we have to be aware of when we're trying to deal with different arrangements that have repeated items. That's what this is about. So the number of distinguishable permutations of n objects, once again the n is the total number of objects, where one object is repeated a certain amount of times and another object is repeated another certain amount of times, and so on and so on. The formula for finding how many arrangements there are for that is n factorial, so the total number of objects factorial, divided by the multiplication of all of those times that one of the objects was repeated factorial. And I want to go over a couple things, so I just want to emphasize that that's n objects. That's the total number of objects. And then we have this word distinguishable permutation, which is not necessarily a familiar word. That means you look at them at face value and you say, okay, that one's different than that one, and that one's different from that one. They're three completely different looking things. Over here we have 6 of them. 6 different arrangements of the word I, but some of these look the same. Like these two look the same, but I just color coded it to show you that there are 2 different E's. If you say, all right, there's one E that's a red E and there's one E that's a blue E, well, yeah, then they would be different. But just looking at the word distinguishably, these are the only 3 different arrangements of that word. So when they're asking for a distinguishable permutation, it's an arrangement that just looking at it, it looks different. It's not like 2 E's that are swapped out. Well, that's the same thing. So the reason we divide out the number of ways is that's how many arrangements that are going to be repeated. So I'm going to jump over to this lovely creation. I made this color-coded craziness. It's with the word even, actually. So this is what the tree diagram of the word even looks like. And you notice there's some circled, some X'd out. That's because some of these were repeated because, well, the E's are going to create some of this very same arrangements of this word, and counting them twice isn't counting all the distinguishable ways. So I had to X out some of those ways. We're actually going to do an example right here, figuring out how many ways there are that are different looking. And we're going to use our formula that should be memorized. So we're just doing n factorial, the number of objects, dividing out all those arrangements of the things that would be repeated. Like in that diagram that I just showed you, there was a lot of things I had to X out because it already happened and I already counted it as an arrangement. So down here, if we're going into this idea of finding a distinguishable permutations for even and the word California. So even has how many total letters? How many different events? 4. There's 4 letters, of which letter is repeated? E is the one that is repeated how many times? 2 times. So the number of permutations of distinguishable permutations that look different from each other, is 4 factorial over, what is it going to be over? Because we have to get rid of all of those arrangements that are going to be repeats. We're using this formula, remember? Anyone have any ideas? Yeah. Yeah, 2 times it was repeated. Up here it's telling me S times an object was repeated. I have to divide out all of those arrangements. Very good, Alec. So we're dividing out all those arrangements that would be repeated. So on the top 4 factorial, that's the same thing as what we got for all the arrangements of math. Do you remember what that number was, 4 factorial? If you don't, it's okay. Yeah, 24. 2 factorial, that's just 2 times 1, that's 2. So how many different ways, how many distinguishable permutations are there for the word even? 12, you are right. And if we jump to, before we do that second part, if we jump to my diagram, well, up here I had 6. Here I had to cross out half of them because I repeated them. If you look here, V-E-E-N, well, I had the same thing here. It's just I was flipping the E's around. Well, you can't tell the difference. Here, I crossed out all of these. They're the exact same as when I started with an E there and there. And then I had to cross out half of those. That's crossing out 12. So originally there was 24, like in the word math, right? Where all 4 letters were different. Crossed out 12 of them, left with 12 distinguishable permutations. Are we okay with why we're crossing things out, why we're dividing out those arrangements? We are going to, you okay? Okay, no questions? Okay. Last example here, applying this formula that has to do with repetition and permutations. California has how many letters? 10? We agree? 10 letters? What's repeated in the word California? Yeah, there are A's, multiple I's. How many of each? 2. So that's 2 I's and 2 A's. Right? It's not just like 2 for both of them. 2 A's and 2 I's. Man. All right, so now we have to think about that formula here. Well, we have 10 letters, 10 events. That's 10 objects. Oh, man. 10 factorial, right? 10 different letters. That's 10 factorial. Now really think here. We have to get rid of all those arrangements that would happen 2 times. Any ideas? Because, yeah, Megan. It would actually be 4, but it's not 4 factorial on the bottom. So our formula up here, we multiply each of the factorials together. Anthony. It is 4, yeah. But it's 4 over here, but that's because we did some factorial work. Yeah, Riley. Yeah, it's 2 factorial times 2 factorial. Because we have to divide out all the arrangements where the A's would be in that location where you're just switching A's. You're dividing out that, and then you also have to take into account the situations where that would occur with the I's. We'd have repeats. So that's that event happening and that. So 2 factorial times 2 factorial does happen to be 4. 10 factorial is a large number. To be specific, it is 3,628,800. So how many distinguishable permutations are there for the word California? Anyone have that number? Noah, what is it? Yeah, you're exactly correct. So we had to get rid of all of those arrangements of the word California that would just look the same because we just switched the A's or something, or we switched the I's to get rid of all of them. Are we okay with that one? Before you go ahead and jump into the independent practice, I want you to try one more. How many distinguishable permutations are there for the word swimming? All right. Noah, can you just tell me in terms of the formula what you put on top and what you put on the bottom? Good. Can I have someone else tell me why he chose each of those numbers? Kristen, go ahead. Right, so 8 letters in the word swimming, 2 letters repeated, M and I, so we had to get rid of those arrangements. And so what is that number? Anyone have that? Go ahead, Kevin. What is it? Oh, 10,000. 10,080. Very nice. Is that what everyone else got? Yeah? Alrighty. Nice job. Alright, so that's where our notes end, and you can start your independent practice, and I'll throw the answers up there once everyone kind of gets going on them. Also, I'd like to come around now and check the homework, so hopefully they have that out on your desk.